So in this video, we're going to find the inverse of a linear function and then verify by composition or function composition that the inverse function that we've come up with is actually correct. So in this example here, we have the temperature model where we predict temperature based on the chirp rate of crickets. So we've seen this one a couple times now. What we're going to do is take this model and find its inverse. We'll then verify by compositions that the inverse is correct. So we'll start by just writing the function down, and it's going to be easier if we drop the of r, the function notation. If we drop that, this will make this a little bit easier. So we'll just write t equals 13/60 r plus the 83 over 2. And then we're going to take and subtract 83 over 2 from both sides, because finding the inverse means isolate the original input variable so that it's now the output. So we need to isolate r to find the inverse function. And remember, do not swap variables. It does not work if you're working with an application model. So we're going to subtract the 83 halves from both sides, which will leave us with 13/60 of an r on the right hand side. We then want to multiply both sides by 60 over 13, which is the reciprocal of the coefficient in front of the r. Not the best parentheses I've ever drawn. So we're multiplying both sides by 60 over 13, and we do that because here we get 60 divided by 60 is 1, 13 divided by 13 is 1, and effectively by multiplying by the reciprocal we generate a 1 on the r. So we get 1 times r times 1 is just r, so now we have r by itself, which is what the goal was, equaling 60 over 13 times the t minus the 83 over 2. And if all the directions indicate are that we are supposed to find the inverse function, we can stop right here, and this is good. We could distribute the 60 over 13 into the parentheses if we needed to get this into slope-intercept form. So we could generate the function r equals by flipping both sides over the equal sign, distribute the 60 over 13 into the parentheses. So we get 60 over 13 times t minus 60 over 13 times 83 over 2. 60 over 13 times 83 over 2. The 60 divided by 2 will equal 30. So we would get r equals 60 over the 13 times temperature minus 30 times 83. That's going to be 83 times 10 3 times. So we're going to get a 90 out of that, and a 8 times 3 is 24. And it's all going to be over 13 times 1 is 13. So we could get it in slope-intercept form if we needed to. The directions don't indicate that we need the inverse in slope-intercept form, so it's easier just to stop right here once we've isolated the variable r. So the next step is, once we find the inverse, we need to verify the inverse by composition, function composition. So we'll start with the original function here. T equals 13 over 60 times r plus the 83 over 2. And then we see that the input variable is r, so this says put r here. And down here, our inverse functions right here says r is this stuff on the left. So I'm going to replace r with its equivalent on the left. So t equals 13 over 60 times r plus 83 over 2. And where r was, we're going to replace it with our inverse function, 60 over 13 times t minus 83 over 2 right here. T minus 83 over 2. And now we want to simplify. So I'll first distribute, or I don't even need to distribute. We'll multiply the 13/60ths times the 60 over 13. This will cancel, giving us a 1. 13 divided by 13 is 1. 60 divided by 60 is 1. 1 times the stuff in parentheses is just the stuff in parentheses plus the 83 over 2. So we get t equals, and then we have a minus 83 over 2 plus 83 over 2 gives us a 0. And we wind up with t equals t. So our first composition checks, we get an identity. We get something that is a true statement. Temperature is temperature. And then we need to verify the composition in the other direction. So this time we'll start with the inverse function, r equals, right here. Start with the inverse function, r equals. What does it equal? It equals 60 over 13 times t minus 83 over 2. And right here we see the t, so we're going to replace the t with the original function. T equals some stuff, and we're going to put that stuff into the parentheses where the t is. So we get r equals 60 over 13 times t, but t is the same as 13 over 60 times r plus 83 over 2. And then t, which is the stuff here, has to have subtracted from it the 83 over 2. The mistake that I see students make here is doing 60 over 13 times 13 over 60 to cancel this by getting a 1. But we can't do that because in this case we would need to distribute the 60 over 13 into all three terms. So the easier approach is to simplify the inside of the parentheses first. Here I have plus 83 over 2 minus 83 over 2 is just going to give a 0. So I get 60 over 13 times 13 over 60 times r plus a 0, which just gives us 60 over 13 times 13 over 60 times r plus 0 is just 13 over 60 times r. And now we have 60 over 13 times its reciprocal, 13 over 60. And anytime we multiply a number by its reciprocal, we get 1. So we get just 1r, which is just r. And we bring the r down from the left. We get r equals r, so it checks. We've gotten an identity. And that's how you verify by compositions that you have the correct inverse function. You should get t equals t, r equals r, and we're done.